Dear students, hello. As I told you, we're going to talk about definitions of the acid and bases by different lecture because of it's really important. So we will stay and we're going to talk about the acid and the bases by detail. In a prior lecture, we mentioned the common properties of the acid and the bases and how to write a chemical reaction in their aqueous solutions for weak and strong electrolytes. And then we show some common commercial acids. But for today, we will discuss about that point according to what base we call some compounds acids and we call some compounds base. For that purpose, we have three definitions. We have three theories, which are Arrhenius acid base, Brønsted-Lowry, and Lewis. First one, Arrhenius acid base. Svante Arrhenius said that acid is a chemical compound. It's a chemical compound that increases the concentration of the hydronium ion in the aqueous solution or hydrogen ion in the aqueous solution. Well, that's Svante Arrhenius. It looks like almost Kurdish man. Arrhenius acid is a chemical compound that increases the concentration of hydrogen or hydronium ion in aqueous solution. So that's the point, aqueous solution. But Arrhenius base is a substance that increases the concentration of hydroxide ion in their aqueous solution again. So that means to deciding that the compound is Arrhenius acid or Arrhenius base, we should have aqueous solution. What? Aqueous solution according to Arrhenius. According to Arrhenius, that man liked water too much. So it should have a swimming pool, according to this definition. For example, we have HCl. HCl, we know that it's acid, but let's discuss the acidity according to Arrhenius theory. If we put H2O in the water, H2O into water, it will produce Cl and hydronium ion. Oh, it increases the hydronium ion concentration. So that means it's Arrhenius acid. Why? Because of the first condition, it's aqueous solution, and then it increases the hydronium ion. You see that? There are two conditions for Arrhenius. The first one must be aqueous. The second one, we should have ion, hydronium or hydroxide. For example, we have NH3. Well, the first condition, right, it's aqueous solution, and then we get hydroxide, and so it's Arrhenius base. You see how it's easy? So for Arrhenius acid and base, first of all, we should sure that it's aqueous solution or not. Then look at the product. If we have H3O, it's acid. If we have OH, it's base. So that's all about the Arrhenius acid and base. Well, there are some notes according to this theory. Well, teacher, so what's the idea of Arrhenius about the acid, about the water? Well, Arrhenius didn't identify that water is a base or acid. So what's the deal with water? Water is only a solvent according to Arrhenius theory. So water is a solvent. Well, water is a dash according to Arrhenius. It's solvent. It's acid? No. It's base? No. So what's water? Water is a solvent according to what? According to Svante Arrhenius. There is no neutralization reaction, I mean acid-base reaction. Why? Because we have two reactants, A, so the second reactant should be water. If we have B, the second reactant should be water. And water, it's not acid, and even it's not base. So how we can get acid-base reaction together? We cannot, because of one of them should be water, and water is not acid and base, it's just a solvent. That's why we did not have the neutralization reaction. Neutralization reaction, it means reaction between acid and base together. According to Arrhenius theory, the principle of Arrhenius theory is that aqueous solution of acid and bases can conduct electric current because of they produce positive and negative ion. Good. Look, any compound that has hydrogen atom is an acid. For example, HCl. Yeah, HCl is acid. What about CH4? Well, I cannot say CH4 is acid because of, for the HCl, it can produce hydronium ion. But in here, no, it don't. It's molecular compound, it's non-electrolyte even. So how we can say it's acid? No. So what's the condition of a compound to be acid with the hydrogen atom is it in its formula? Well, the hydrogen atom should be ionized to form H3 or look. No, any compound that has hydrogen atom is not acid. The compound should have acid and should have H, and that H should be ionizable, then we can say it's acid. No, acids are molecular compound with ionizable hydrogen atom. Okay? Even look, NaOH. NaOH has acid, has H plus, but it's strong base. We cannot say it's acid. Okay? So, if you don't understand from this example, but it is very clearly, any compound that has hydrogen atom is the acid? No. In here we have a hydrogen atom, but it's acid or base? It's base. So no, the hydrogen atom must be ionizable to form a hydronium ion. For example, CH4 molecule has 4 hydrogen atoms and they are not ionized because of, that's why CH4 is not acid. Because all 4 hydrogen atoms are non-ionizable. They bonded to the carbon by strong covalent interaction. Which of the following is an Arrhenius base? Oh, Arrhenius base. What are the conditions of the Arrhenius base? First of all, should be aqueous, should be dissolved in water, aqueous. Then we should get OH. Okay. Here is a gas. No, it's not. NH3 is aqueous. Yes, teacher. Because if we put NH3 into water, NH3 aqueous, it means NH3 plus H2O. It can produce OH plus NH4. So this is aqueous, and we get OH. So it's Arrhenius base. NaOH, it's base, right? No. It's solid. It should be aqueous for Arrhenius. So it's not right. All of them, no. So the right answer is NH3 aqueous. But if that question said, which of the following, or the aqueous solution of which of the following will be Arrhenius? If the question said, if we have aqueous solution of each of them, which of them becomes a Arrhenius? So all of them. But in here, no. Which of the following is Arrhenius base? Only that's aqueous solution, and it's base, so it can produce hydroxide ion. So we are sure that it's Arrhenius base. Look, although HCl aqueous accepts properties of the Arrhenius acid, but pure HCl gas or HCl in non-polar solvents exhibit none of the properties of the Arrhenius acid. Exactly. And explain why. Look, it means, it said that if we have HCl aqueous, we can say it is Arrhenius acid. But for HCl gas or HCl in non-polar solvents, okay, it's not Arrhenius. Why? Look, HCl aqueous, it means HCl plus H2O. Okay, I don't know what happened. Let's write it again. In here, it's better. There's a better place. HCl aqueous means HCl plus H2O to producing H3O plus ClO. In here, we get hydronium ion and it's aqueous, so we are sure that it shows the Arrhenius acid properties. But for HCl gas, we don't have water, so it cannot ionize. So if we don't get H3O, how we can say it's Arrhenius acid? No, because of they cannot ionize. We don't have any ion. That's why HCl gas or HCl in non-polar solvents, we cannot say they are Arrhenius acid. So we should be in the water, and then in the product we should get H3O. The second theory is Brønsted-Lowry theory. There are two different scientists. They are worked individually. This is Nicholas Brønsted, and this is Thomas Martin Lowry. Okay? We have the explanation of the acid and bases according to a new theory, which is Brønsted-Lowry theory. Brønsted or Brønsted doesn't matter. Brønsted-Lowry theory. Acid is a molecule or ion. Oh, in Arrhenius said acid is only a molecule, but Brønsted said no, it's molecule or ion. Oh, now it's ion even. That is a proton donor. It means a proton releaser. A proton releaser. But Brønsted-Lowry base is a molecule or ion that's a proton acceptor, proton receiver. So now we have two new expressions of the acids, but in here we depend on the proton. If the molecule or ion accepts a proton, it becomes the base. And if it releases a proton, it becomes a acid. Well, in here, HBr plus H2O to producing H3O and Br. Well, now identifying a proton donor and proton acceptor. HBr converted to Br. So it's proton donor. It's donor. Not that donor when we eat in a turkey. It's proton donor. It means proton releaser. H2O converted to H3O. Oh, it's proton acceptor. So H2O is a proton acceptor, but proton donor is HBr. So a proton donor is an acid. So HBr is acid, and water is a base. So that's one of the differences between Brønsted-Lowry with the Arrhenius theory. Arrhenius did not identify that H2O is acid or base. He said that H2O is only a solvent, but in here we see that water is a base because of its proton acceptor. Well, another example. NH3 plus H2O. Well, water in here is a proton donor, so it's acid. Water is a proton donor, so in here we have water as an acid, and this is base. So did Brønsted-Lowry identify that the water is a base or not? Yeah, of course. If water is a proton acceptor, it's base. If water is a proton donor, it will be an acid. According to what? According to Brønsted-Lowry. But what about Arrhenius? No, water is only a solvent according to Arrhenius. Look, HCl is a proton donor, NH3 is a proton acceptor. So a proton donor is an acid, proton acceptor is the base. These above mentioned reactions are Brønsted-Lowry acid-base reaction. Well, another difference between Brønsted-Lowry and Arrhenius. In Arrhenius, we did not have any acid-base reaction. Why? Because of one of them always should be water, and water is only a solvent. But look, in here, all of these reactions contains acid-base, base-acid, acid-base. So do we have a Brønsted-Lowry acid-base? Yes, we have Brønsted-Lowry acid-base. Do we have Arrhenius acid-base? No, we don't have Arrhenius acid-base reaction. In this reaction, look, in this reaction, HCl plus H2O, suppose that it's black color, it's not green, we don't know the right answer. HCl plus H2O to producing H3O plus Cl. Water is, well, Arrhenius said water is nothing except of a solvent. So Arrhenius base, no. Arrhenius acid, no, because Arrhenius said water is only a solvent. Well, water accepted a proton, so it is Brønsted-Lowry base because of it accepts a proton in this reaction. NH3 plus H2O to producing NH4 and OH. Water is, well, water donates a proton to producing OH. So it will be Arrhenius base? No. Actually, Arrhenius, it was a real enemy of water because he said that water is nothing except of a solvent. So it's not possible. Arrhenius acid, no, it's not correct. According to Arrhenius, water is a solvent. Brønsted-Lowry base, does water accept it or release it? Release it. So it's Brønsted-Lowry acid. The right answer is the green color. According to Brønsted-Lowry, well, we have many discussions about that. So memorize that things as it is. This reaction, HCl plus KOH to producing H2O plus KCl. This is acid-base reaction to producing water and salt. Okay. It is Arrhenius acid-base reaction. No, Arrhenius did not have that property. Dissociation, no, it's not dissociation. It's Brønsted-Lowry acid-base. Well, let's see. We have a proton donor and proton acceptor, so it's Brønsted-Lowry acid-base. Single displacement? No, definitely. This reaction, of course, again, is Brønsted-Lowry acid-base, so all questions have the same idea with each other. The last definition, which the broadest one between them, it is Lewis acid base. It's American chemist Gilbert Newton Lewis. Actually, it's Gilbert Newton Lewis. Well, it's not our deal, but this is Lewis also. Even it looks like a Kurdish man, but he is very sad. Okay. Lewis acid base. Lewis acid, what is the definition of Lewis for the acids? Lewis said acid is an atom. Oh, now we have another thing, atom also. Ion or molecule. Look. From the starting of the definition, we can see the difference between them. Arrhenius said acid is only a molecule. But Brønsted said, no, acid may be ion or molecule. And now Lewis said, no, acid is atom or ion or molecule. So which of them is the broadest one? Of course, Lewis. That accepts the electron pair. It deals with the electron pair. It deals with the electron pair. Okay, this definition deals with the electron pair. So it deals with the electron pair. To form a covalent bond. Oh, covalent bond. Now, if we say that compound, when accepts electron pair to form a covalent bond, it will be Lewis acid. Lewis base, so it will be a contrast to Lewis acid, is an ion or atom or molecule that donates an electron pair to form a covalent bond. This theory deals with the pair of electron. Now we have some rules to identifying Lewis acid base. So if Lewis acid likes to receive a pair of electrons, so it should have empty orbital to occupying by these two new electrons, but Lewis base should have free pair electron. Okay? Cations such as Ag, hydrogen, etc. are Lewis acid, but in here, in contrast, we have anions such as iodine, chlorine, bromine, OH are Lewis base. So anions are Lewis base. Any compound that includes aluminum, boron, Fe. Any compound that includes aluminum, boron, Fe. Look, BAlF. Okay, we say balif. In Kurdish, balif, pillow. Well, any compound that contains aluminum, boron, and fluorine, they become a Lewis acid. Okay, such as BF3, AlCl3, and FeCl3. Any compound, especially organic compound that has nitrogen, will be an Lewis base. But here is Lewis acid. Well, now let's solve some examples about Lewis acid and base. And let's see what the special thing is for that theory. For the following reactions, identify Lewis acid and bases. Well, look, in here we have cation. Did you remember what I said? Cations are Lewis acid. So it will be Lewis base. Do we have Lewis acid base reaction? Of course we have. NH3 plus BF3. Oh, it contains boron. So it will be Lewis acid. Lewis acid is BF3, NH3 is base. H plus NH3. Oh, we have cation. So cation is Lewis acid because it has the empty orbital that can receive a pair of electrons. BF3 plus F. Oh, this is anion. I'm sure that it's Lewis base. And this BF3, I'm sure that because of it contains a boron, so it's Lewis acid. Look, do we have water in here? No. Do we have hydrogen and hydroxide? No. So tell me something about the Arrhenius. Use Arrhenius theory to identifying acid and base in these reactions. No, we cannot identify because they are not aqueous solution and we don't have any OH and hydronium ion. Well, so Arrhenius theory is useless in here. It's useless. Well, use Brønsted-Lowry theory to identify proton donor and acceptor. No, we don't have any proton donor and acceptor, even in here. So even Brønsted-Lowry theory becomes useless for that kind of reaction. So how we can identify? We have the broadest one, which is Lewis theory. That's why Lewis is the broadest one between them. Because of if we have any compound that it is acid, according to Brønsted-Lowry and Arrhenius, it will be acid according to Lewis also. But if we have any compound that's acid according to Lewis, they are not acid according to Brønsted-Lowry and Arrhenius. That's the special point of the Lewis theory. Let's see if we have some equations. Yeah, we have that equations. So we have that questions. Excuse me. Look, why H plus is a Lewis acid? Because it can receive a pair of electrons to form a covalent bond. It's very easy. When ammonia formed a covalent bond, because of it mentioned a covalent bond, ammonia we know that it's base, and it formed a covalent bond, so it's Lewis base. Which of the following is a Lewis base instead of Brønsted-Lowry acid? It means it will be a Lewis base, so it can be detected by Lewis, but cannot be detected by Brønsted-Lowry. HCl, yeah, HCl is acid. It's totally wrong because the question is about, well, HCl is wrong. Why? Because of HCl can release a proton. NH3, no, NH3 can receive a proton. F, it's base, no. So the right answer is BF3. BF3 is Lewis acid. They are base and totally wrong. So we are only have to be sure about HCl. That's Lewis or Brønsted-Lowry. HCl can release its proton, so it will be Brønsted. But in here, no, it's only Lewis. That's why BF3 is the right answer. Okay, here we have the last questions. In this reaction, Ni2 plus NH2O to producing this complex compound. Actually, we get this equation in the second term of the final examination for previous year. But, well, again, we're going to solve it. Well, water is, because of its cation, so it's Lewis, it is Lewis acid, so it will be Lewis base. Water is a Lewis base. And this reaction, water is, look, water is, this is acid, this is base. According to Brønsted-Lowry, it's base or not. Look, water just received a proton. So that's why it's Brønsted-Lowry base. It's right. What about Arrhenius base? No. As I told you, Arrhenius is a real enemy of water. It did not identify the acidity and basicity of water. Lewis base, of course, it will be Lewis base. So the right answer is A. Okay? بام شوية كوتاي بوانەی ویدۆزەکان دەهێنین. ئینشاءالله لە بابەتی ئەمفۆتیری و ئینشاءالله لە بابەتی ئەمفۆتیری و ترشەباران و هاوکێشبوون پێتان شاد دەبمەوە. ئەوەی گرنگ بوو دەربارەی ئەو تیۆریانە چۆنەتی خوێندنی مەرجەکانیان بوو. لویس لە هەمیان گشتگرتر بوو ئەوە لەبیربی. باشە؟ تاوانێ داهاتوو بەخواتان دەسپێرم. هەر شاد و سەرفراز بن، خواتان لەگەڵ.